So hello everyone, and welcome to Nimonik's EHS webinar series. Today's webinar will touch upon rack safety and compliance. I'll give everyone a quick minute to settle in before we begin, so make sure to grab your cup of coffee or a glass of water, and then we'll start. Thank you. Okay, so let's get started. Today's webinar will cover the inspection of racks, its latest practices, and the standards regulating it. But before we begin, I'd like to briefly introduce Nimonik as a company, my role here, and of course our presenters for today. So Nimonik is a software service that provides EHS managers with the tools necessary to ensure environmental, health, safety, and quality compliance in their operations. Nimonik is both a web service and an app that is designed to help auditors inspect their facilities for compliance issues, as well as stay on top of legal updates and maintain a legal register. My name is Kim Chanel. I am the Communications Manager here at Nimonik, and I will be the one facilitating today's webinar. So please feel free to ask questions throughout the presentation in the GoToWebinar question box, and we will gladly address as many as we can at the end of the presentation. So now to present this topic to us today, we have Tony Mulholland and Brian Rusciolelli from Rack Networks, who specialize in the field of storage systems engineering. Simply to give our attendees a bit more context, Rack Networks is an ISO 9001 certified engineering firm that serves users and providers of storage equipment. And Tony, one of the experts with us today, is the head of this firm. He has more than 30 years of engineering experience with racking and has also been instrumental in the development of industry standards. So that's it for my little introduction. I am happy to say that we have attendees from all over the world joining us today. So thank you all for participating. And without further ado, here are Tony and Brian on rack safety and compliance.
Hello, and thank you for joining us today. I am Brian. I will be starting the seminar here, and we'll start with our agenda and basically tell you what we're about to cover. We're going to start with the terminology and an introduction to storage racking, including the various types of racking as well as their vulnerabilities. Then Tony's going to take over and give you an understanding of the standards and how often your racks need to be inspected. We will be describing the process of inspection and the appropriate response when you find damages. And finally, we will be looking at the capacity and ensuring that your racks are not overloaded and that they are compliant. So you will see here just a simple diagram of a typical rack structure found here in North America. The racks consist of frames and beams. Frames consist of posts or columns as well as braces. As you see, we have the posts and the braces are what connect the posts together. We do diagonal posts as well as horizontal braces. The beams are what actually hold the pallet, so they support the load at all times. And a beam bracket is what actually connects the beam to the post or column. On the beam bracket, we insert a safety pin. This ensures that the beam cannot be disengaged easily when lifting product from below. The side profile here shows you a so-called connected row on selective racking. They are connected by row spacers, usually found along the second horizontal, and then anywhere from 8 to 12 feet above or just near the top. This slide shows just a blown up view of the post and the diagonals and horizontals. Basically, we see the post upright or column. Generally, you can have a post protector. This is a guard that helps deflect any collisions with the front of the post. The base plate and shims, these are what actually are in contact with the concrete slab at all times. We usually use shims just to make sure that it's balanced throughout the entire row. And of course, an anchor in the back. Of course, base plates do come in all shapes and sizes. We do like to see 3 inches of embedment for an anchor. Horizontal and diagonal braces, we do like to see this orientation in facing the aisle, just to kind of give a little more shear impact strength from the aisle blows. So the first type of racking that we are going to look at is the selective racking. It is by far the most common type of pallet rack that you will find in facilities. The rack is arranged in a single or a series of rows in which every pallet that you put on this system is accessible at any given time. You will normally find the damage in the lower 5 feet, or as we like to say, from your eye level down. Posts and braces in this section are by far the most common that you will find. The diagram on the right shows you 3 connected rows, and you can see the orientation of the braces are sticking out into the aisle to add to that impact strength. Collapses are rare in the double rows. However, we say that up to 10 times as likely to fail if it's a single row than it is a double row, as a connected row offers a little more structural redundancy than a single row does. The second type of racks that we will look at are drive-in racking. These were pretty common in the late 80s, early 90s. However, they are starting to not be as common. As you can see, it's exactly like the name suggests, where the forklift operator will drive directly into the tunnel and into the rack structure to either load or offload the products. The rails run the length of the tunnel on both sides and support pallets on their edge. It is really important that you do not use broken pallets and you use the correct type of pallet in this rack system. As you see, there is top bracing along the top, the X bracing, as well as the back bracing you can see in the middle aisle there. This ensures the added support laterally, as you do not get that as you would with the selective rack, as there are no beams going across the tunnel. You will see damage along these rear frames, as unless there is a stop for a pallet stop at the end of the rails or on the floor. This is because you push them until you can't push them any further, and the back bracing gets damaged in the process. As well as on the lower 8 feet of all the uprights going through the tunnel, because of the interaction with the forklift and the tunnel. The collapse is prone, especially if you do not find this top and back bracing. And in order to inspect it properly, we ask that you unload every second tunnel all the way to the top, not just the bottom, as you do not want to be walking underneath any product at any time when inspecting a rack structure. The difference here is it's kind of like a beam bracket, however it's a stub that sticks out and then the rails are connected to it. Other than that, the frames are essentially the same with 2 post braces. The third one is pushback racks. These are becoming more and more popular and replacing drive-in racks, actually. So it is very similar to a selective rack structure. However, not every pallet is accessible at any time. The first pallet is usually put onto a cart, and then the second pallet pushes it back, and so on, depending on how deep your pushback structure is. Very important when you are taking pallets off of this that you take it back slowly and you do not allow the cart to come crashing forward. Damage is typically you would find on the lower front post, as the other frames in the back usually don't get it as much damage, and the carts can be hung up if not properly maintained, or if broken pallets or shrink wrapping is falling off. They can kind of hang up the carts and the carts could potentially fall off. The collapse is very rare because of everything is tied in together, from the frames being tied together to all the beams with the rails going back. Everything's tied together, so it is very structurally sound. Finally, we're going to look at the cantilever racks. These are very simple looking racks. They consist of a column with perpendicular arms used to support longer items such as lumber or steel. The arms are always angled back in towards the post. However, over time, they can start angling down, and that is when the damage is caused by dropping loads too heavily on them, and they can start to fail that way. The collapse are rare due to the robust construction, unless they are, of course, constructed in-house, especially when they are constructed of wood. You see the pole is open there. So, as you can see, the majority that you find in your facilities are the selective or the double deep, and the other ones are pretty much similar in their frequency found in facilities across our listeners here today. Thank you for taking part in that. We just want to kind of show you a little bit of the rack accidents. They happen, unfortunately, across the world. We're not going to spend too much time on this slide. We just want to basically show you that it happens. It still happens today. As you can see, in March 2016, unfortunately, there was a rack collapse. People were injured and one person passed away. We invite you to search videos on YouTube. Many workers have witnessed a collapse of sorts, I'm sure. But if you want to see what type of collapses can happen, you can definitely spend hours on YouTube looking at that. So I'm going to pass it off to Tony now, and he is going to take you through the rest of the slideshow.
Thank you, Brian. As per the introduction, I've been involved with standards for rack for quite some time. Actually, many years ago, I originated or was instrumental in the creation of the CSA standard, A344. And at that time, we didn't really have any user's guides worldwide, and so we were kind of the first one. But from a global perspective, there may be some that I haven't captured here, but the main ones are the American MH16.1, which is produced by the Rack Manufacturers Institute. It has been around since, I believe, probably the 60s or 70s in terms of being a standard for the design of rack. The Europeans got into the process of standardization and produced a whole series of standards. Some are very specific, but the one that we often cite is this 15635 because it is a user's guide. And today, most of our slides and our references will be made to A344. It's the prime standard in Canada. It's also generally exceeds or meets most of the content that's in the RMI and the EN standards. And I should also mention that most of the references are to the A344 2006 version. Now, this version is still in draft. However, it's gone through all the technical committees, gone through public review, and now all it needs is a relatively short little distance to go before it's formally voted in and published. So we might as well be sticking with the most recent standards. There's a poll going on right now, and thank you very much for participating. And it looks like from the poll, it's pretty much an even mix between CSA and the RMI standard that most people are familiar with or practicing. So now going into the content of A344. Clause 8.1.9 calls for two types of inspections. One is called routine inspections, and the other one is called expert inspections. So the need for expert inspections is very much following the European lead. In places like the UK, they've had this as a requirement in the workplace for quite some time. Now you ask, perhaps, what is an expert inspection? It is not an inspection by someone that's been around rack for a long time or someone that knows how to install rack. Expert inspections are an inspection that is done typically by a non-engineer. However, the overall process, the training, and all those elements that are required to have a quality inspection are done under the supervision of an engineer, and the engineer would take responsibility for the process and for the inspection. And that's key. It's called oversight, and it's basically how our world of safety works. Public safety, rather. Everybody always wants to know how frequently we would do an inspection. Most workplace regulations would call for a monthly inspection of the workplace. I find that almost universal in most occupational health and safety acts, and you're also allowed to extend that over longer periods of time if the workplace is of a large enough size. But here in HB 44, we put the responsibility of determining the frequency onto the expert inspector, and he generally uses a concept of risk analysis. So risk analysis usually is a analysis that looks at vulnerability on one axis and risk on the other. Anyway, I don't think I got that quite right, but don't worry about it. Anyway, the illustration here shows you that if there's a lot of activity and a lot of throughput, you'll have to have more frequent inspections. For example, if you have a facility that's running 3 shifts a day and you have a lot of temporary workers, then you may be quite high on the one axis. And also, if you have on the other axis rack that is easily damaged or is not well protected, you'll also end up in an area of higher risk. And the combination of that and the frequency of damage that we see during the inspections will determine the frequency of your inspections. And it could be anywhere from 6 months to 24 months, typically. When we're looking at damage to rack, we sometimes internally here use the term red, amber, green, or the RAG method. It's first appeared as a method for categorizing items that are observed in inspection in the European standards, and then it found its way into the Canadian CSA standard, and in the most recent edition, we've revised some of our thinking, and it's solidly enshrined. When we're doing an inspection, as you'll see in another slide coming up, there's a lot of things that an expert inspection considers in addition to just damage. People often wonder what kind of process is used when doing a rack inspection. In some cases, they believe that people should be using scissor lifts and they should be going up in the air and the rack should all be emptied. This is a very expensive process, and when using that sort of a process, it makes inspection cost prohibitive at the risk of perhaps having people not do it as frequently or perhaps foregoing it altogether. So in CSA H344, they indicate that it's generally done from the ground level, with the focus on the ground level or the areas that you can see from ground level. And it's not done by using scissor lifts. And in addition, it is done with the racks loaded. Except for perhaps, as we mentioned earlier, on special racks like Drivein racks, where you simply cannot see the rack from the outside of the system. Or another example where we would use man-up situations would be any kind of a tall rack that involves cranes, because you simply can't have the visibility of the upper areas. The amount of damage is typically the focus of most standards, and is also the case in the European standard. In the CSA standard, we've chosen not to use 1,000 millimeters or 1 meter as the distance in terms of how we'll measure damage. Instead, they use 500 millimeters. Distance is chosen simply because it's easier to get a 500 millimeter straight edge and to examine many components or members within a rack frame. This chart that's before you right now is not necessarily representative of the chart that's in the European standard, and it's representative of what you might get from an expert inspection company who is looking at your particular rack. For example, it recognizes the difference between single rows and connected rows, the difference between a diagonal brace and a horizontal brace in a particular type of bracing arrangement. And as the example shows, the limit would be 4 millimeters on a diagonal in a single row as opposed to 5 millimeters in a connected row. I indicated earlier that there is a variety of different factors that go well beyond the actual measurement of the amount of damage that is present. And I'm not going to go through all these little items here, but you can well imagine that they are all significant. I'll just talk about the first one, for example. Failure mode of a member or a component within the rack. Posts tend to buckle. Buckling is a phenomenon that can happen quite rapidly, and once a post begins to buckle, all of its strength is relinquished, and you're going to get a collapse. And a collapse typically is an event where you can call it catastrophic, and there's a lot of risk to anybody that might be in the zone. And it can also result in progressive collapse throughout a facility. So that being the failure mode of a post, we may want to think of it differently than, say, the failure mode of a beam. A beam that is connected to a post on either side, when it goes into a failure mode, it typically starts to twist and it starts to sort of shed the load or not support the load in an expected fashion, or it allows the load to lean a little. But typically it will still support the load, and the load will not fall into the aisle. And so we would be a lot more stringent when we're looking at damage on a post than we would on a beam, perhaps because we would be looking at its failure mode. That's just one example of what you might be looking at when you're deciding how severe damage might be. Just wanted to touch quickly on the subject of rack engineering or structural engineering concepts. I think you're all probably familiar with this concept of buckling, where as you increase the distance between the floor and the first beam, or between successive beams, you lower the capacity of the upright considerably. And it's not a linear relationship. If you can dramatically affect the capacity of an upright by 3 to 4 times by doubling the distance. Also of note is the function of bracing. Not everyone appreciates how important bracing is in a frame, and that if it is damaged, it is essentially crippled, and its functionality is severely affected. And yet it is a very, very critical member in a frame. And as the illustration on our right-hand side shows, the upright can easily go into a buckling mode if the bracing has been crippled or damaged. And finally, I just wanted to mention that when we look at buckling of an upright or of a post, there's always 2 types of buckling. There's weak axis buckling and strong axis buckling. So buckling about the XX, for example, axis, that is affected by the distance that we have between the beams, whereas buckling about the YY axis is affected by the distance between the bracing. And so the removal of, say, a horizontal brace accidentally could double the buckling length of the YY axis and dramatically affect the capacity of an upright. One of the salient features of the A344 standard is it really doesn't give you any limitations as to what amount of damage is allowable. It solidly puts the responsibility of doing so on the expert who would be inspecting your facility. If you happen to be in a seismic zone, then these limits would be quite a bit narrower. If you happen to have members who that are such that they lose their strength considerably due to a small amount of damage, then you will also have much tighter restrictions on the amount of allowable damage. Also, if you have a system where you have very, very high utilization of your capacity, you might also find yourself with tighter restrictions. So this is a matter for each facility to establish for its various types of rack up front, and it may vary from site to site. Most people are familiar with the limitations on the post and on the braces, but there are other members within a rack structure that can also be examined and limits put on it. For example, the amount of twist that can occur in a post can be an area of focus, or the amount of damage and where the damage is on a beam can also be an item of focus, and limits put upon those damages, especially if you find them reoccurring within your facility. And the chart here, as you can see, is establishing limits for out of plumb, post twist, beam damage, and various types of frame damage. This here slide is intended to show you that inspection is very much a process, and the process has various stages. And I think you can see that there's find, classify, implement immediate action, and specify corrective action, and finally closing out the observation or the item that you put on your inspection. It also shows the concept of red, amber, and green, and it also tells you what you would do in each case. For example, red is always a put out of service, and yellow is not. Yellow allows for continued use in the condition that you have observed. This is a little different here with CSA than in the European standard. The European standard says that once identified as yellow, you're not able to reload it, but yet you do not have to unload it. It was the position of the technical committee that that was a very difficult thing to implement and control. So we chose to say that if it's amber, you can continue to use it, but remediation should occur at some point in time. And finally, you got your green condition, which is something that is of minor nature and doesn't require corrective action necessarily or unloading, and it can also deal with operating practices. And of course, there's one that doesn't have color. You can see on the bottom there, bad operating practices, and they too have to be identified and examined and possibly have training and revised practices put into place. Also in this here slide, you see that the classify area or the tagging is very instrumental, and we suggest that you always identify any red, yellow, or red, amber, green items and do it with a tag similar to what you see on our slide. The reason for this, even in the case of a green item, is that you do not want it to be reoccurring on your inspection week after week. Again, thank you for participating in the poll, and the results are coming in. As I might have expected, caution tape appears to be the #1 way of identifying and blocking out damaged locations. Although it is not the most elegant of methods, I do happen to know that it is very common. The slide we have up right now, again, is dealing with the concept of risk analysis or risk index, and you can see that our practice typically is to identify numbers that are related to the 3 colors, amber, green, and red, each having 3 degrees. This allows us to refine our inspection process and understand how bad might be. And there is a matrix shown here that establishes the relationship between consequence and probability. So if we were to examine something like a safety pin and its absence, it allows us to examine how we would rate that item. Well, the probability of a beam becoming disengaged and thereby dropping the beam loads that are placed upon it are somewhat unlikely. That's because a number of events have to occur for that to happen. And some of those events would require an operator to be not paying attention to, for example, the fact that he's just disengaged a beam or that he's loading a beam that has been disengaged. On the other hand, the consequence could be rather significant if a load were to drop into the aisle, which is probably the number one cause of beam failure. Whenever we hear of beam failure, it's almost always a case of a beam being disengaged, loaded, and then a cantilevering force on the upright occurring and the load being dropped. So, as I was saying, the probability is rather low, but this consequence is rather high. And so we would probably assign typically a 2 or a 3 maybe to that. But this is an important concept. In addition to assigning a score, we also have to think about whether or not we want remedial work to be done, something to be done. And so as an inspector, we would always assign something like a 4 to a 6 to that, most likely a 4. So we're not going to have to unload those levels that have a missing safety pin, but instead we would make sure that a safety pin would be put onto it. Another feature of the CSA standard is that it puts the responsibility of determining how much time is going to be allowed for various corrective action to occur. This is a result of observations made in the field where when doing expert inspections year over year, we sometimes find ourselves putting stickers on top of stickers. In other words, no corrective action has happened over a 1-year period of time. And you can see that various kinds of choices that someone might make as an expert are illustrated in this table. And that can change from location to location and from component to component. For example, if you know that it's a special frame and it's about a 16-week delivery, you might allow a considerably long time for that frame to be repaired. I'm going to turn this mic over right now to Brian, and he can talk to a few of these slides, and he'll bring it back to me in a short while. Thank you.
Thank you, Tony. So as you see right now, we've differentiated 2 types of unloading. So a total unload, you can see on the diagrams where the X is, X marks the damage, and judging by the severity of the damage, we can then suggest a total unload or a partial or center-to-center offloading. So a total unload is usually, if it's a red, judging from the slide before, an 8 or a 9, so to speak. And that is where you unload every single pallet on either side of the frame, all the way up, or above the damaged location. Typically, we'd like you to unload from the top down, always, never from the bottom up. The partial or center-to-center offloading, we want to satisfy that center line of the beam. So in the diagram we show just a simple 2 pallet beam size. However, if there are 3 pallets, such as you would find normally in a tunnel beam, you still need to offload that middle pallet to satisfy the center line to center line of the beam. So when marking damaged rack, the CSA does actually call for a method to clearly identify the rack that is unsafe by marking or tagging, as many of you suggested that you use caution tape. This diagram does show one way to tag out a level or a bay. As you can see, you can just use dry eraser. And this actually tells the next shift or the next operator in the aisle which levels not to load, if it's all the levels or if it's just a localized level due to a damaged beam. This can give all of the information necessary, so he doesn't have to go looking for something. He knows exactly what's wrong all the time. Tony's going to go over a case study with you.
Often we find that when we do rack inspection, expert rack inspections, we also have a training program associated with it. And along with that comes a rack awareness for the employees. The training is usually delivered to a select few, but they become the ambassadors or the disciples of rack safety, and they get the message out to other people vis-a-vis the Health and Safety Committee, and we have a general overall better understanding of the implications of rack damage, and that, along with the process of eliminating the damage that is present and before everyone's eyes, changes sort of the corporate or the company attitude towards damage. It's so much easier to damage rack with impunity when all around you is damaged. But when all the damage is repaired and when damage occurs, it's the focus of everyone. It's quite instrumental in changing the way in which the workplace views damage. And these are real numbers from a major retail distribution center. And as you can see, when we first did the inspection in 2010, there were over 200 items that we found. And the next year, we sort of tightened up the belt a little bit and found even more items. And finally, we got down to year over year of only 34 items being found. But interestingly enough, the job was not done. Different things can occur, and the number or the rate of incidents can climb up again. For example, the people that may have been trained and the disciple action of them may have dwindled, and people are now becoming unaware of the importance of racks being in good shape and not damaging them. And so the numbers can rise back up. And so we found that, and then there was some training put in again, and then the numbers came back down to sort of a normal level of about 30 items per year. So what we found when we look at this, and when you consider the average cost of a rack repair being something like $200, or if you're using repair techniques, is that rack inspection is actually something that can result in an overall cost savings to a facility. And it's very, very important that the process identify any situation where things are getting away from you, because once rack becomes ever present and pervasive within a facility, it's usually an indicator that the life of the rack is rapidly coming to a close, because it's going to be damaged so badly within the next few years that you may actually be looking at rack replacement at possibly huge costs. A lot of people, and including our audience today, wants to know about load plaques and load signs. And so we have a little focus on here. And what I'd like to say is that a load plaque by itself is only one half of the formula. Really what we are trying to do is make sure that the weight of the loads put in the racks never exceeds the capacity of the rack. That is our goal. Not just having knowledge of the rack capacity, but rather having knowledge of what the load is, the weight of the loads are that you're putting in the rack and how they add up. So in order to achieve our goal of not overloading the rack, we can use a number of techniques or tools which generally don't, and in some cases they generally do not rely on the plaque. For example, our warehouse management software system can limit the load going into any particular slot location. And often this is done not only for the purpose of the rack, but simply because lift trucks cannot lift heavy loads high up into the racks. If you use load plaques and you have awareness of the weight, in other words, tagging of all the pallets so that an operator can clearly see what the weight of the pallet is, that's another method. trained operators using approved storage procedures also works. For example, if you're at a facility and you know you have play sand and bottled water as your two heaviest products that cannot go into the racks and they always go on the ground, you can control your loading such that you don't exceed the capacity of the racks. And finally, and probably the most common of the methods that we experience, most facilities just simply set the capacity of any given beam location or slot location at 2,500 pounds or 3,000 pounds with the knowledge that nothing that comes into their facility exceeds that weight. And by doing so, they in essence control any kind of a situation where a rack can be overloaded. Where plaques are used, it's very important that they include a reference to whatever document that established that capacity. It's no longer acceptable, in my mind, or in the view of CSA A344, to have a load plaque where you have no idea whether it's current and how it was established. You have to be able to have traceability back to a particular document, which most likely will bear the seal of a professional engineer, and you will be able to also, with that document, validate the construction of the rack and the location of the rack within your warehouse and establish that indeed the plaque is valid. Sometimes what you can do is if you're putting various plaques throughout the facility, you can have one central plaque that brings and sort of amalgamates all the other plaques into one mountable document or plaque that does this here. That concludes our sort of technical information for the day. And so it brings us to our final slide, which just brings up the various things that you may now want to be considering as next steps. As you can see from today's webinar, the expert inspection or expert inspector is essential to the process. And so you should probably be looking towards who might be able to provide that service to you, because a lot of what gets going here is established from that contact. You don't need to wait for that expert inspector to make sure that you have engineering documentation and compliance documents that establish the capacity of your rack. But he will hopefully identify it if you don't, because I often say that's the first thing you inspect when you do an expert inspection is the documentation. If you don't know the capacity of your rack with a great deal of certainty, then you have a potential overload. You have your first inspection item. Anyway, I encourage you all to go right into that and ensure that they are you not only have those documents, but that they are up to date. They truly do reflect the configurations in your warehouse, and they also are reflective of the types of rack and the layout of the rack that's within your facility. Time has a way of changing things. Thirdly, you have to set up a program, or should consider setting up a program. And along with that comes the need to make sure of making sure your employees are trained to do the work that you're going to call them to do. I should mention at this time that often the third-party inspection company is able to do that training, and to do it on a cost-effective way, it's often done while he is on site doing his expert inspection. And typically that training comes in the form of a 2 to 3 hour seminar that gets into additional items that we have no time for in today's webinar. Fourth, you will have to respond to the inspection, which is going to require you to repair the racks or replace the various components within the racks. It should be mentioned that if you are doing any repairs to racks, these repairs need to be formally approved. If you do not have formal approval of the various repairs that you are making, you're essentially accumulating this liability that sooner or later a labor inspector or a joint health and safety committee or some other regulatory agency is going to bring the repairs into question, and they may consider them to be modifications as opposed to repairs. And so it's very important that you have them formally approved. And finally, depending on what you might have in your expert inspection, there will be a need to do other types of changes to your system. For example, there might be aisles that are too narrow. There's a whole lot of things that can kind of come out of an expert inspection. Poor lighting, for example, would be another thing. And you will find yourself having to implement the various types of recommendations, or at least consider making change where the expert inspection has identified various types of deficiencies. So that concludes our webinar for today in terms of us providing you with information. And I believe now we are going to move over to questions.
Yes, so I think we have a poll right now in progress. If you want to talk about that, Tony, before we step in the Q&A.
Sure. The poll is still coming in. And I believe the question is, do you have any formal rack inspection training? And it's kind of a dead heat between yes, no, and today is our only. So I would say that it looks to be like about a third of the people on the webinar today have had no formal rack training. And that doesn't surprise me. I know in the United States, finding rack training is rather difficult. Up here in Canada, 2005, with the first release of the A344 standard, there was a development of a training program to go along with it. And so that training program has been offered quite a few years now. And I'm not aware of any kind of training programs that I do happen to know that in Europe, or at least in the UK, and I attended one just to see what it was all about, training programs for rack inspection are prevalent, and in fact they have two levels. They have one for inspectors, and they have another one for those that are doing the routine inspections. So it does appear that about 66% or so of the people on our poll prior to today had no rack inspection training.
Great. So thank you, Tony and Brian, for that incredibly informative session on rack safety and compliance. We went a bit overboard, but we're going to continue with a 5 to 10 minute Q&A if you would care, if our attendees would care to stay with us a bit longer. So please drop down any last minute questions you may have, and then I'll proceed to share these with our presenters. But before I do, I just wanted to quickly point out that rack inspection checklists provided by Rack Networks will be made available on Nimonik's platform after this presentation. So please feel free to give us a call or send us an email for more information. And with that in mind, we'll tackle a few questions. So the first one here I have is formal training required for internal rack inspections?
Most occupational health and safety acts require that employees be trained for the job function they have. If their job function is to inspect racks, then they should be trained to have the necessary skills to do so. So the answer is yes, there should be training if that is one of your job skills that is required. Perfect. Also, it's noteworthy that when accidents do happen in the workplace, my experience is that it's typically the charges that are laid is failure to train employees. And so if you don't have trained inspectors, then you may be vulnerable to that sort of charge as well.
Okay. We have another question here for you. So do racks have to be leveled with the load capacity?
I think we covered that with the plaquing, and I would say that they don't, but there should be some sort of compliance plaque that's placed up in the workplace. And I'll also add one more thing that I didn't say during this seminar, that the CSA standard actually makes special notation that you are not to label beam capacities. They're for too long we've seen racks with a beam capacity placed upon it, and then what happens when we multiply the beam capacities out by the number of beams, we find out the upright is being overloaded. So we have to be very careful when labeling rack capacity that we are putting a capacity on it that is representative of the structure capacity, not the capacity of any particular component.
Perfect. So I have another question here for you, Tony. Would wire guided help prevent damages, especially in drive-in racking?
I have yet to see any kind of a wire guide system for drive-in racking, but it could possibly be done. Instead, drive-in racking usually has guide rails placed on either side, so or sometimes we call them rub rails, that essentially controls the travel of a pallet at the ground level when it's being put in. Of course, then once we get to the upper levels, it's the rails that essentially establish the position of the pallet. So yeah, for drive-in rack, I don't think so. In other types of rack, wire guided is very useful and prevents a lot of damage. But it puts in a heightened requirement that pallets are at the ground level are properly inserted into the slot position, because if they happen to by accident be too far out into the aisle and the lift truck hits the pallet, there's usually quite a bit of calamity that's caused. So once we're into a wire guided situation, usually the rate of travel down an aisle and the mass of the vehicle is such that if anything gets in its way, we can take out 2 or possibly 3 uprights all in one collision. So wire guide is very effective, but it also has this very unique nature to it that it allows for rather dramatic accidents to happen when something is placed unexpectedly in the path of the truck.
Perfect. Another question here for you. Wouldn't the safest way to prepare an upright replacement or repair be the total unloading?
Oh, any kind of replacement requires total unloading, and it actually requires perhaps even one additional measure. It's also very important that if you're going to change an upright out, that you look at the upright behind it and ensure that that upright if it's in a connected row, is in very good condition, because it could actually be relying upon the one that you're about to change out. So yeah, any kind of rack repair or any kind of upright replacement would require full unloading. Now we did talk about center to center unloading today. That's typically it should have been mentioned. That's typically an expert inspection alternative, and we use that sometimes because when we go into facilities with a lot of damage, the operational effects of calling for total unloading can be considerable and introduce quite a bit of an operational difficulty to a facility. So we can lessen that effect by specifying various types of partial unloading. In our experience, most routine inspections done by non-experts would typically just call for total unloads, not center to center partial unloading.
Awesome. So we have a great question here. How do you handle rust on racks? When should the racks be taken out of service due to rust?
Rust rarely, in an inside condition within a building, rarely is a factor. When racks are placed outside, they usually require some degree of corrosion protection by galvanizing. Paint usually doesn't work that well. The nature of these of rack posts, and because they're relatively thin, doesn't allow paint in itself to provide protection if the rack is outside. And the other exception is in the grocery industry, they sometimes have wet rooms. And wet rooms also can cause a lot of corrosion on an upright, and anything going into a wet room would have to be galvanized. Generally speaking, a little bit of rust on the outside, well, when I say the outside, typically the rust will be more visible on the inside of the column, where the paint didn't get full access to the metal, and it's not going to be detrimental to the structural performance of the upright. But the minute you start seeing what I call flaking, the minute you can actually take an instrument, a key or something, and scrape it against an upright, and you see a flake come off, then you're actually starting to work with the base metal thickness. and you have potentially a situation where the upright could go into failure in the lower zone. And yeah, and it's usually, by the way, rust when we see it is usually in the lower zone, the lower 2 or 3 inches of an upright burr where it's making contact with the floor.
Great. So another question here for you. So from an OSHA perspective, which standard must we be using in the US?
What we talked about today primarily were user guidelines. And although I said RMI, RMI has MH16.1, but it also has a user's guide. So you're free to use whatever user guide you want. And maybe I'm a little bit partial to A344, but I find that it's 2016 that we're talking about. So and we're working with a body of knowledge that came from all the training that we've been doing since 2005. And so I find the CSA user guideline a very good one. When it comes to design, it's another matter. In the United States, the building code often dictates what the racks are going to have to be designed for, and in that case, it's the ANSI MH16.1 standard, and in Canada, actually, it's notable that the 2015 National Building Code is going to require racks be designed for seismic and will be then subject to building permits, and the design specification will not be A344, it'll actually be our Canadian Structural Steel Code S16. They've actually removed that back half of the A344 standard 2005 version. All the design stuff is now gone, and it's over in our other standard S16 Canadian Structural Steel Standard. So yeah, if you're getting an engineer to approve your rack capacity, he should be aware of what is the applicable standard for that jurisdiction. And it would vary between Australia would be different, England would be different. So you've got to look at the applicable standard for your jurisdiction.
Perfect. So we have a lot of questions in our question box, but unfortunately, we can only go on with one last question for today's webinar. But do not worry, everybody that has asked a question in the question box will be answered by email. So Tony, here's the last question for you for today. Do all rack beams, front beams, need to be labeled with capacity labels, or is it acceptable to label the end beam of the row if the entire row is the same capacity?
As I was saying, typically we don't want to label all beams. It's not a good process at all. Even if you were to label all the beams with a capacity that respected the capacity of the overall structure, it might not be a good practice. And the reason is it's hard to read those beams way up in the air, and also it's hard to change them. And you could very well get yourself into a situation where you're making some sort of change to your beam spacing below, which affects your capacity of your bay, and it's so much work to get up and change all those labels that you're not going to, and then you're going to basically have your capacity inaccurately labeled. So beam labeling is not all that recommended. On the other hand, we do recognize that there may be a label put on a beam that's down at ground level on occasion, and that may be done because you know that specific bay has something happening in it where there's a special capacity that's less than what might be, say, labeled at an end of a row or in the central plaque that covers the whole facility. In other words, your whole facility may be good for 2,500 pounds of pallet, but there's one particular bay where you've got something happening where because there's a lot of beam levels within it or whatever, and it's only good for 2,000 pounds, and so that might be the one bay that would get a label, and that label would be placed on a beam, say at the 4-foot or the 8-foot level or where it's visible. But generally speaking, mass labeling of a facility is not a recommended practice for a variety of reasons, including the difficulty of ensuring that they are current and accurate.
Great. So I was asked by an attendee to send you all of the answers to the questions remaining. And since we have a lot of them, I think that's a great idea. So do not worry, we will do this later on today. So thank you so much, everyone, for asking these very interesting questions. And of course, thank you, Tony and Brian, for giving us this informative presentation. So if anyone has any last-minute points, I would then redirect you to info@nimonik.com, where we'll be able to answer any questions. Please note that we will send you a copy of the slides and the recording of this presentation later on today. So one last big thank you to everyone. Have a great day, and we'll hopefully hear from you soon.
Bye, everyone.
Thank you.